this video going to introduce scientific notation. Actually, this is going to be a very short video because scientific notation is something you've probably been exposed to for quite a bit in math classes. So I'm going to assume that a lot of this you already know. I'm going to quickly go over it, give you some choices or preferences you may want to consider, and then after that, pretty much should be it. So the whole thing about scientific notation, what I've listed up here is a very generic format. Sometimes we've got numbers really, really big. Sometimes we've got numbers really, really small, and we do not want to write them all the way out. So we put them in this format of one digit to the left of a decimal point, and then all the other digits after it, to times 10 to some power. So, and that exponent can be positive or negative. So that's how we want to do it. Now, do I care how you put answers in scientific notation or not, or I should say when? No. Here's what I would say to that is if the textbook, or if I specifically say put it in scientific notation or do not put it in scientific notation, then follow that. Otherwise, it is your preference what you do, as long as you are obviously following significant figures rules and you're doing that rounding correctly. All right, so just briefly here. Let's say you've got a really, really large number and you want to put it into scientific notation. What that means is if it's a really, really large number, you're going to have the exponent be positive. So what do you need to do? You basically need to move the decimal point to the left, and however many times you move it to the left, that is what your exponent is going to be. So 3,270, that's where it's understood the decimal point is. I'm moving it 3 to the left to get it in the format of 3.27. Okay? Again, don't put up the 0 because there is no decimal point there. It's not significant. So 3.27 times 10 to the third because we moved 3 places. We take it out of scientific notation. If we see a positive exponent, that means we move the decimal point that many times to the right. So 6.842 means we're going to move the decimal point 1, 2, 3, 4, 5 places. Now, we do not actually put a decimal point because, again, we only use it if the figures are the digits are significant. Again, I'm not trying to confuse anybody. If you guys know what you're doing with significant figures, then don't worry about it. May have to just tweak it a little bit with dealing with significant figures. Those of you that aren't quite sure about scientific notation and may or may not have had it a lot in math class, then obviously you probably need to pay attention a little bit more. All right, let's say we've got a really, really small number, a number less than 1. So how do we deal with scientific notation there? Well, first of all, numbers that are really, really small, less than 1, we're going to be changing those so that they have an exponent that is negative. It's important to remember. So let's say we've got a really, really small number. That means we're going to have to move the decimal point to the right to get it in the correct format. And again, therefore, the exponent will be negative. So here, I need to move the decimal point 1, 2, 3, 4 places to the right to fit it in the correct format to get 4.27. I moved it 4 to the right, therefore negative 4 as the exponent. I'm going to take a really, really small number out of scientific notation. If I have a negative exponent, that means I have to move the decimal point to the left that many places. So I'm going to move the decimal point 6 places to the left. 1, 2, 3, 4, 5, 6. And there's my number. Again, do not necessarily want to spend a lot of time on that because if you know how to put them in and put them out, that's great. Your calculators can default to always putting it in scientific notation, which can be good and it also can be bad because if you forget about it, you're going to get an answer that's rounded maybe to the wrong place. So just kind of be careful about that. The next 2 slides here, I'm just putting up for convenience. This is a personal preference. If you don't want to do this, you do not have to, but this can save you some time from actually having to pick up your calculator and type in or punch in all these numbers. So if we're adding and subtracting, a couple things you can think about that's the shortcut. So you can look at this, you can kind of write down the notes. If you can follow it, great, and if you see it in the book, great, and if you want to use it, great. If not, don't worry about it. But what it basically leads to, if we're adding or subtracting, if we have the same exponent, we just add the numbers to get our answer. the exponent carries down. Again, same exponent, we just add the numbers together. That's our answer, and then we just have to readjust the final answer to fit the correct scientific notation format. Again, you can look over that. You can write this down if you want to, pause it, and look at some more of the examples in the book. Multiplying and dividing. I guess here's just one more example that you can look at. Again, we're putting in scientific notation, moving to the left or right, what you got to do. There's one more example. And again, at any point I'm going too fast, just pause me. That's the nice thing. You can't pause me in a classroom, but you can pause me right here on the computer. All right, multiply or divide. Again, first thing is nice. You're going to you just multiply or divide the base number. So you go here, where multiplication, multiply the two numbers together. Divide the two numbers together. That's what your base number is. Then, if we're multiplying, add the exponents. 4 plus 3 is 7. If we're dividing, subtract the exponents. 10 minus 4, negative 2. It can save yourself a little bit of time if you're able to do some of those calculations, sort of in your head. Again, you can look at these examples. If you understand it and it can be useful, then use it. If not, that's fine too. All right, so that finishes up scientific notation. Like I said, it was going to be a short one. Again, look at any of the examples that are in the book. So if you feel more comfortable using scientific notation in either doing calculations or rounding final answers so that they are in scientific notation, that can be very useful too.